Very good morning, my dear students. Today, now we are going to discuss the topic thermochemical equation, standard enthalpy of reaction, heat of combustion, then molar heat capacities. The last one, relation between Cp and Cv. These are the topics present in Unit 7 Thermodynamics. So let us discuss. Question number 1. What are the convention adopted in thermochemical equation? A thermochemical equation is a balanced stoichiometric chemical equation that includes the enthalpy change del H. The following convention are adopted in thermochemical equation. The first one, let us see the equation. When we write the thermochemical equation, as usual, we have to write the reactants and the products. Then equation must be balanced, left side and right side. Thereafter, physical state also we should mention. The physical state of reactant, whether it is solid or liquid or gas. Product side also we should mention it. Then enthalpy reaction, enthalpy of a reaction, that also we should mention. Del H or the superscript 0 means standard. What is the value, whether it is a positive or a negative. So in this equation, delta H or delta H of reaction, standard reaction equal to minus 967.4 kilojoule. Okay. Now we see the convention. Point number 1. Regarding the equation, the coefficient in a balanced thermochemical equation refer to a number of moles of the reactant and the product involved in the reaction. So when we balance the equation, number of moles, 2 hydrogen and 1 oxygen, they give 2 moles of water, right? So point number 2, the enthalpy change of a reaction delta HR has to be specified with the appropriate sign and unit. As I told earlier, for the equation you should write delta HR value, standard value, whether it is negative or positive. Point number 3. Point number 3. When a chemical reaction is reversed, the value of del H is reversed in sign with the same magnitude. Here I have given the 2 equation. The first equation is reversed, so product act as a reactant, reactant act as a product. So when we write the reaction as reverse, del H value sign will be changing. Here negative, here positive. So when we write any thermochemical equation, the reversible reaction also we can write it. But you should remember one thing, del H value sign also has to be changed. Point number 4. The physical state, gas, liquid, aqueous, solid, mentioned in the bracket in the each reactant and product of all species are important and must be specified in a thermochemical reaction, since del H depends on the physical state of the reactant and products. Point number 5. If the thermochemical equation is multiple throughout by a number, the enthalpy change is also multiple by the same number. For example, the first equation we see is multiple with the 2 means 4H2, then 2O2 gives 4H2O. So reactant and product multiple with the same number. The delta H value minus 967.4 kilojoule, that also multiple with the 2. It is one of the convention in thermochemical equation. So these are the points for has to be followed in thermochemical equation. Point number 6. The negative sign of delta HR indicates the reaction is exothermic. Exothermic means heat is liberated. So when the delta H R value, standard value, enthalpy of reaction value is negative, negative means exothermic, heat is liberated, and the positive sign means indicates endothermic, heat is absorbed. Let us move to the second question. How to calculate standard enthalpy of a reaction? So delta H R, how to calculate standard enthalpy of reaction? Let us discuss the question. The standard enthalpy of a formation of ethyl alcohol, carbon dioxide and water are minus 277 is for ethyl alcohol, minus 393.5 is for carbon dioxide, and then minus 285.5 kilojoule per mole is for water respectively. Calculate the standard enthalpy change of the reaction. The first we should write the equation. The equation also provided in the question. So ethyl alcohol oxidized, they give carbon dioxide and water. The balanced equation also given. So we have to find the enthalpy of formation. We have to find the enthalpy of a reaction. Enthalpy of a reaction. Here regarding the equation, left side, reactant side, oxygen enthalpy of formation, standard state is 0. Standard state is 0. So in the question, ethyl alcohol enthalpy of formation is given, carbon dioxide formation is given, then water standard enthalpy of formation is given, but oxygen is not given, but oxygen standard state is 0. Now look at the formula for the equation. So this is the formula. Enthalpy of a reaction, standard enthalpy of reaction equal to enthalpy of formation product, standard enthalpy of formation of product minus standard enthalpy of formation reactant. Regarding the formula, we have to substitute the value. First you should write the moles. Carbon dioxide 2 moles, water 3 moles. So it's a product minus reactant. Ethyl alcohol 1 mole, oxygen 3 mole. Okay. Then delta HF for CO2, delta HF for water, delta HF for ethyl alcohol, delta HF for oxygen. Just you substitute the value. The values are substituted. Now the product side value minus 1643.5. So right side minus minus plus 277. Finally delta H R enthalpy of a reaction, standard enthalpy of reaction equal to minus 1366.5 kilojoule. Okay, let us discuss question number 3. What is heat of combustion? Heat of combustion. It is important. 3 more question. The change in enthalpy of a system, nothing but delta H. For combustion means suffix we should write C. When 1 mole of a substance is completely burned in excess of air or oxygen, it is denoted by delta H C. Delta H C. For example, carbon is reactive with the oxygen, is a combustion reaction. So we can get carbon dioxide. So how much amount of the 1 mole of a substance, that is a carbon, is completely burned with the oxygen, right? They give a carbon dioxide. So what is the delta H value regarding the combustion? Delta H C equal to minus 394.55 kilojoule per mole. So you have to take a 1 mole of a substance, that is a carbon, so completely burned in excess of air, that is oxygen. They give carbon dioxide. So delta H value in the combustion we can calculate minus 394.55 kilojoule per mole. That is called heat of combustion. Question number 4. What is heat capacity? What is heat capacity? Here, Q directly proportional to mass. Q means what? Q, when heat is supplied to the system, that is called Q. Q is directly proportional to mass multiplied with the del T. Del T means change in temperature. Change in temperature. So when a substance undergoes on heating, the initial temperature and the final temperature, we have to measure it. Initial temperature and final temperature, we have to measure it and multiple with the mass, that is directly proportional to quantity of heat that is supplied to the system. That's what is given. The molecules in the system absorb the heat, hence their kinetic energy increases, which in turn rises the temperature of the system from T1 to T2, initial to final. So we can find the change in temperature T2 minus T1 is directly proportional to the amount of heat absorbed and mass of the substance. That's why Q directly proportional to mass into del T. Now the directly proportional has to be removed. So we have to write one constant value with equal to. So Q equal C mass into del T. Now from the second formula we can take a C. C equal to Q by M del T will come. C equal to Q by M del T. The C multiplied with the M and del T, it will go to the left hand side. So Q by M del T, C. The constant C is called heat capacity. The constant C is called heat capacity. So next question. What is specific heat capacity? So just now we have seen heat capacity. Now we are going to see specific heat capacity. The same formula we have to take it. The difference in temperature should be 1 Kelvin and mass 1 kilogram. Now the heat capacity is referred as specific heat capacity. From the heat capacity, we have to make a condition. What is the condition? Mass has to be 1 kilogram and temperature difference should be 1 Kelvin. Let us see the formula. C equal to Q m del T del T. How to write it? T2 minus T1. Now m equal to 1. Change in temperature also 1. So C equal to Q. That is called specific heat capacity. Question number 6. What is molar heat capacity? What is molar heat capacity? The heat capacity for 1 mole of a substance is called molar heat capacity. It is defined as the amount of heat absorbed by 1 mole of a substance to rise its temperature by 1 Kelvin. I repeat it, the amount of heat absorbed by 1 mole of substance. So you have to take a 1 mole of substance in which the heat is absorbed and the temperature is raised by 1 Kelvin. That is called molar heat capacity. Molar heat capacity. Now, what is the unit of heat capacity? So regarding the formula, Q by m del T, the Q, quantity of heat is supplied. So heat unit joule, right? So joule divided by mass, 1 mole you have to take it. So mass, it is in denominator, so mole inverse. Temperature unit Kelvin, Kelvin also present in denominator, so K inverse will come. Joule, K inverse, mole inverse. That is a unit of heat capacity. So regarding the formula, we can write it. Now, what is Cp and Cv? What is Cp and Cv? The molar heat capacity can be expressed either at a constant volume, that is Cv, and a constant pressure, Cp. So Cp, Cv are called as a molar heat capacities. According to the first law of thermodynamics, as we studied earlier, U equal to Q plus W. Work is done on the system, right? Internal energy equal to heat supplied plus W, work is on the system. The plus W, the pressure volume derivation, how to get it? Minus P del V. Just you substitute the place of W minus P del V dV. So U equal to Q minus P dV. Now Q equal to, Q will come into the left hand side, U will go to the right side. So now Q equal to U plus P dV will come from the first law of thermodynamics. Now, next what you have to do that, differentiate this equation with respect to temperature at a constant volume. So constant volume means dV equal to 0. dV equal to 0. Now dou Q by dou T at a constant volume equal to dou U by dou T at a constant volume V. The suffix V mentioned as constant volume. This equation is differentiated with respect to temperature at a constant volume. So next, so what is Cv? Molar heat capacity at a constant volume. Cv equal to dou U by dou T at a constant volume. That is Cv. Now likewise Cp, molar heat capacity at a constant pressure, can be defined as the rate of change of enthalpy dou H by with respect to temperature dou T at a constant pressure. So Cp equal to dou H by dou T at a constant pressure. So Cv and Cp, keep this in your mind. It's derived from first law of thermodynamics. Question number 9. Write the relation between Cp and Cv for an ideal gas equation. It is very, very important. 5 more question. H equal to U plus Pv. So from the enthalpy definition, we can write it H equal to U plus Pv. First you should write it. Next, Pv equal to nRT for ideal gas equation. That also we have to write it. Now, the third step, the place of Pv, we can substitute nRT. So H equal to U plus nRT. Now, the fourth step, differentiate the above equation with respect to temperature. So dou H by dou T equal to dou U by dou T plus nR dou T by dou T. So dou T by dou T cancel. So we can get dou H by dou T means what? Cp. Dou U by dou T Cv plus nR. Now the Cv will move to the left hand side. Cp minus Cv equal to nR. That's all. Now question number 10. How to calculate del U and del H? Del U and del H. First you write Cv du by dt. Dou U by dou T or du by dt, we can write it. Now, the cross multiplication du equal to Cv into dt. Second step. The third step, for a finite change, we have the d we can consider as del. Del U equal to Cv and dt consider as del T. So del U equal to Cv del T. Now, change in temperature, just we can substitute. Del U equal to Cv, the place of del T, how to write it? Final temperature minus initial temperature, Tt minus T1. T2 minus T1. Now, for n moles of ideal gas, we can get it. Just you substitute is n number of molar heat capacity at constant volume. So del U equal to n Cv d2 minus T1. Similarly, del H also we can write it. Del H equal to n Cp T2 minus T1. So change in internal energy and change in enthalpy we can write. The Cp and Cv is for molar heat capacities. Thank you.